In this video, we're going to learn how to calculate molar masses from chemical formulas. Just remind ourselves that the molar mass is actually the mass of 1 mole of a substance, and its units are expressed in grams per mole. In chemistry, we're going to need to determine the molar mass across a number of different scenarios. For example, we need to determine the molar mass for atoms and elements, for molecules and molecular compounds, as well as for ions and ionic compounds. So let's start with elements. Let's consider the differences or the similarities between measuring the atomic mass of an atom or an element versus its molar mass. Both will have the same magnitude, but different units. The units for atomic mass are atomic mass units, whereas the units for molar mass are grams per mole. So if we use sodium as an example, the way we're going to determine the molar mass of sodium is to look up sodium on the periodic table. We see that its atomic mass is 22.9898 atomic mass units, and we can simply write down its molar mass from this number, 22.99 grams per mole, to 4 significant figures. And it's worth noting and remembering that the mass of 1 mole of sodium is therefore equal to 22.99 grams. Similarly, for another element, the argon atom, we'll look up argon on the periodic table and we'll see that its atomic mass is 39.948 atomic mass units, so we can write its molar mass down directly from there into 4 significant figures. We would write it down as 39.95 grams per mole. And again, the mass of 1 mole of argon being 39.95 grams. Now for molecules, the two things that we're comparing, it's not atomic mass now, it's molecular mass versus molar mass. But again, the molecular mass for a substance and the molar mass for a particular substance will have the same magnitude but different units. Molecular mass, like atomic mass, has atomic mass units as the unit, whereas molar mass is grams per mole. So if we look at the molar mass for water, H2O, we will look up information about both hydrogen and oxygen from the periodic table, and we know that the water molecule contains 2 hydrogen atoms and 1 oxygen atom. So to calculate the molar mass, 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen, and we'll get 18.02 grams per mole as the molar mass. And again, it's worth noticing or worth mentioning that the mass of 1 mole of water is 18.02 grams. Essentially, we're going to do the same for ionic compounds. For ionic compounds, we talk about the formula mass rather than the atomic mass or the molecular mass. Compare that to the molar mass. Again, the formula mass for a particular ionic compound has the same magnitude as the molar mass for that compound, but again different units. Like atomic mass and molecular mass, the units for formula mass are atomic mass units. The units for molar mass, as we know by now, grams per mole. So the ionic compound calcium carbonate contains calcium, carbon and oxygen, so we would need to go to the periodic table to get information on those 3 elements. We know that the formula unit for calcium carbonate contains 1 calcium atom, 1 carbon atom and 3 oxygen atoms, and we would sum the molar masses of those 3 atoms. So 1 times the molar mass for calcium, 1 times the molar mass for carbon, and 3 times the molar mass for oxygen. Put that into our calculator and we get 100.09 grams per mole. And again, it's worth noting that the mass of 1 mole of calcium carbonate will therefore be 100.09 grams. So calculating molar masses, exactly the same principle as calculating atomic masses or molecular masses or formula masses. Only the units will change. They'll change from atomic mass units to grams per mole.